Hello, everyone. I'm Dave Rubenstein, Editor-in-Chief of IT Ops Times, and welcome to the third and final episode of our Network Observability Microwebinar series with Broadcom. With me again today is Jeremy Rosbach. He's the Chief Technical Evangelist at Broadcom, and he's going to be talking about 10 ways to get your network ready for AI. So, Jeremy, go ahead. Take it away.
Thank you, Dave. Again, really great working with you. And in this third installment of Broadcom's mini-series on network observability, the first one, we talked about the state of network operations. The second one was about how to gain visibility into current challenges that involve cloud and ISP visibility, because that's where the user experience for network delivery lives mostly now. And now we're going to look to the future and figure out if networks are really ready for AI. Everyone's talking about AI. I was at the Open Networking user group, that sponsored the AI Networking Summit last week in New York. Everything's AI. We're all talking AI, but no one's talking about how to prepare our networks for AI. We're going to talk about some of the challenges that AI is going to dump on our networks and the already out-of-the-box ways you can use Broadcom's network observability software to get your network ready. So let's just dive right into it. Just setting the stage here. This is directly from Meta. We all know Meta, the parent company of Facebook, but Meta is already doing AI, as we all know, and this is data from the time that their AI workloads spend on the network. So whether they're passing data, analyzing data, grabbing data, whatever, computing data, whatever the case may be, the network has those AI workloads delivering it 57% of the time. So 57% of the time, your network is moving data for AI workloads, passing data, collecting data, et cetera. So over half the time, AI workloads are spent on the network. Again, another reason why we need to get our networks ready, right? Here's another one. AI's demands on today's network. So we're just going to concentrate on the right side here, everything in red, but we can see that massive data sets are coming and we expect bigger data volume for generative AI network traffic on today's networks. East-west traffic within clusters, so GPU to GPU of passing data. So those traffic patterns are new to network operations today versus just east-west traffic, between virtual network devices, physical devices, et cetera. Extremely high bandwidth requirements are going to be needed for today's networks for implementing AI. Extremely low latency will be expected, if not no latency at all. I'm sure I've talked about, the fact that if there's any packet loss, any latency, any congestion within a AI workload and its computation, you may not get the right answer. Right? I mean, I've said this before. If I only have 8 out of the 10 ingredients for my recipe for dinner tonight, it's not going to taste the same way as if I had 10 out of 10. So you can just see the massive amount of impact AI workloads are going to have on today's network. It's not anything we've seen before, and I'm not going to read all these, but from any part of the network, when it comes to observability, whether it's latency, packet loss, jitter, congestion, topology, movement, you name it. We need to figure out if our networks are really ready for AI workloads. But today I'm going to talk about 10 ways you can use existing capabilities and features to get ready for this type of challenge. And then real quick, from our own data and our own study done this year, not only is AI going to be a challenge for our networks, it's also going to be a challenge, obviously, for our network operations teams. So currently, 77% say that network operations is more complex than it was years ago, obviously to do with the pandemic and hybrid working and cloud adoption and the more use of ISPs instead of traffic inside the data center. 82% report visibility blind spots because they're using more ISP cloud and SaaS adoption. Again, makes sense. The user experience and network delivery does not really exist as much as it did within the four walls of the data center where we are network gods. And then finally, 41% cite that they cannot hire skilled workers to meet these challenges. So we got to get the network ready. We just have to. we thought SD-WAN and software-defined really challenged our network operations teams. AI is going to turn everything upside down. So let's get right into it. Number one way to get our networks ready for AI workloads is to implement, if you haven't already, some type of isolation, fault isolation, alert suppression, because nobody needs that much noise in their NOC when they're trying to find the root cause. Cisco ACI can produce 23,000 events. Nobody needs those events clogging up their alarm console when they're trying to find the root cause. So patented isolation and algorithms that suppress downstream events, that take thousands of alerts and surface only one alarm based on those alerts. That's how you get to root cause quickly and easily inside or outside of the four walls of your data center. We'll talk about more of that outside observability that we can gain inside of unmanaged networks like ISP and cloud. When you have alarm suppression, or excuse me, event correlation and other types of downstream suppression, the alarm noise can be reduced. So again, you can see here over 7,000 events, but only one alarm in this alarm console on the right. So being able to quickly and easily isolate the root cause, quickly and easily troubleshoot, having data within one click to be able to understand where the root cause is, the congestion, the bottleneck, et cetera. This is all what makes, these capabilities are all what makes a lot of our customers say they have a 75% improvement in mean time to repair, or 99% reduction in alarm noise. It's true, and it works. Another way to get ready for AI workloads for our networks is being able to move from that one alarm to every device metric on that specific device that we need to help analyze the problem situation. So the more data you have, the more insightful intelligence you have. So whether it's SDN or interface health or discards or voice or telemetry or logs, etc. You see everything here. This is the data that's needed to quickly and easily point to the root cause. If you're not looking at logs, and let's say a switch, maybe it has an optical port, and the only way it writes optical errors is in the log. Well, again, you could be looking for a needle in a haystack if you're not collecting that log data along with everything else. So more data, more insightful insights, and quicker root cause. And then taking all that data and being more proactive on it, right? Being able to understand when thresholds are breached, especially with unmanaged networks like ISP and cloud providers. You can set thresholds on the infrastructure you're using from them for your customer experiences and network delivery, to be able to understand what device inside their network may have breached packet loss or latency or congestion, et cetera. And you can obviously always do this inside of your four walls of your data center on the infrastructure you own, to be able to easily and quickly deal with an issue that has breached a certain threshold before it impacts more and more customers. And then from thresholding to predictive capacity analytics. So again, taking all that data that we've been analyzing and reporting on and correlating and normalizing, and then saying, listen, within 30 days, 60 days, 90 days, 120 days, et cetera, this is what we expect this performance to look like with this device, with this interface. Always great information to be able to proactively understand what you may need down the road from your network. I mean, especially with AI, right? So if this was an AI workload use case, we would see maybe capacity becoming fuller and fuller and needing to be updated, or we can see latency. If it continues to not be fixed, it's going to grow more and more, and obviously obscure our AI workloads and their calculations. All really good information to help build resilient networks for our AI workloads in the future. And then, I mean, it's been around forever, but it's still one of the top 5 reasons why there are network outages today is configuration compliance, just basically missing a line, deleting a line, typing something wrong in the config and then saving it. We've all done it. I've done it in the past. So having an observability solution that understands the devices, the network devices that are supporting your AI workloads, and any configuration management changes that have occurred that could bring down that network, bring down that AI workload, cause disaster. So being able to understand changes that were made automatically, alert you, and roll those back to known good changes so a configuration outage does not affect your AI success. More out-of-the-box features include topology analytics. So it's always wonderful to be able to visualize the AI-ready network that you're now building for your AI workloads to understand the relationships and the dependencies. On the left-hand side, you're looking, just at a typical layout, but on the right-hand side, you're looking at SD-WAN tunnels, and all the dependent relationships and devices, whether it's the overlay or underlay that make up that architecture. Again, being able to understand what's read, what's been suppressed behind it, concentrating our efforts, clicking on these devices to see the latest performance metrics that have been collected on it, all improves triage times and resolution times when AI workloads really cannot have any type of performance degradation or outage, even minutes of it, let alone days or even weeks. Volatility analytics, again, being able to understand from, let's say in this case, an interface point of view on your network devices that's supporting your AI workloads, how volatile has the performance been on this device or on this interface? So being able to understand current and future volatility. This is just to make network operations teams aware of where something might occur down the road that is beyond just capacity, running out of bandwidth, more users on the segment. This is about very granular information into congestion and blips and even security use cases. All being able to understand the relative volatility among your network and how volatile those network segments may be in the future, according to performance data we have collected. Number 9, and this is where it gets really, really exciting, where we've taken all the data, we've taken all the blind spots and removed them, and now get data from not only inside the four walls of our data center, but then over underlay and overlay statistics from SD-WAN and WAN statistics like packet loss, latency, and jitter, and then moving into ISPs, home Wi-Fi for our hybrid workers, cloud networks. You're looking at end-to-end network paths here from a certain source out to a certain cloud destination. And so being able to understand every device in that network path, even if it's in the ISP networks or the cloud networks, I know we're not gods of them, but there is a way to collect very important data from them to understand where the root cause is or to find your innocence, right? So listen, I talked to the head of network operations with a big consulting firm last week in New York City, and they said they have all this. They can see latency across the entire path. They can see packet loss across the entire path. But I asked him, can you tell me which device in the network path is causing the latency or packet loss? And he couldn't. He just knew there was latency or packet loss along this network path, but could not find enough information to claim he was innocent and his team was innocent. And you can blame the ISP or cloud provider if that is the case. And that's the differentiator with Broadcom. Finally, number 10, synthetic network testing of ISP and cloud performance. So it's not just only collecting data and being passive about waiting for something to break, even in these unmanaged networks, but synthetically sending user information to these websites and monitoring the milestone steps of whatever they do in those apps, right? Open it, log in, click this, buy that, hit your shopping cart, check out. What is the network delivery experience for this application for our end users? Is the network, if some device inside of Verizon Fios's network is dropping packets and we see it, what is its effect on the application experience for our end users when it relates to network delivery? Well, it's dropping packets. Maybe that's why we're seeing logins taking 4 seconds instead of 1 second, right? This is all great information, especially to take back to the cloud and ISP providers. And I have one bonus one, which is really the icing on the cake. It's number 11. It's active performance validation of ISP and cloud networks. So being able to understand end to end from user to cloud, from client to cloud, whatever the case may be, every single hop in that network path, which is usually outside of your data center. Right here, you can see data losses happening in a Microsoft Azure network, and it's their device. So not only have we collected a lot of data on the infrastructure we own, but now collecting data on the infrastructure we don't own to understand the entire network path. We're actually getting packet loss information that has breached a threshold that we set, that we talked about earlier, so we can instantly understand when that threshold has been breached. And then look at this. In the example I gave you about the large consulting company, and the guy said he could see latency across the entire network path, but couldn't find the device that was causing it. This is that answer. We can see this device, 104.44 blah, public IP address in the Microsoft Azure network, is having data loss greater than 2%, little low, but for demo purposes, it fits the bill here. So, reducing alarm noise, collecting the right data, being proactive on that data, understanding, capacity planning on that data, and proactively understanding what the data is going to tell us 30, 60, 90 days from now with performance. Collecting data from unmanaged networks like ISP and cloud providers, using that data to understand exactly what cloud providers' networks may be, how they may be performing, and ISP networks are performing for your end user experience. And then being able to understand with all that data and pinpoint the specific culprit device that is causing issues for your end users and their network delivery experiences of the apps you supply to them. So you can't get any granular than this. Pinpoint root cause, even in unmanaged networks. This is how you get your networks ready for AI workloads. If you're not looking at packet loss, your AI engine is not going to be looking at packet loss. And if packet loss is the cause of getting some weird computation from an AI algorithm that you didn't expect, this is the reason why we're hosting this webinar today. And it's the reason why all those features I just showed you is the reason why we're number one. We've been number one for years in the analyst reports that report on network observability, and we're very proud of that, as well as being ranked number one by our peers. So again, really enjoyed this mini-series. Please reach out to me if you would like to talk more about any and all of these use cases. And listen, you don't need 1,000 eyes to pinpoint the issue. You just need one expert. So Dave, back to you, and thank you so much.
Yeah, thank you, Jeremy. One thing that you mentioned earlier in the presentation is that almost half of the people who responded to your study said they lack the skills that are necessary in this changing world with more complexity and more blind spots and things they can't control. What kind of specific skills are you talking about that people need and don't have or can't find?
Yeah, that really shocked me too, because I grew up in the age in the 90s and the early 2000s where IT was the hot job to be in, right? You too, Dave. I mean, there was way too many folks applying for IT jobs than there were jobs. Now it's the opposite. And all I can gather so far after talking to analysts and other peers is, the generation that's coming up now, they don't really know there's a network. I mean, they do, but they, they're Bluetooth in here, they're, connecting their phones there, they're sending texts, it's just not thought of anymore. And then with the adoption of cloud and now AI, folks are looking to be more cloud architects or, get into the AI field.
Right.
I'm hearing a lot of SD-WAN architects are either being let go or they're shelving the project because of various reasons, budget, et cetera. But it's those granular level 3 architects and engineers that are deploying a lot of software-defined technologies as well. They, I really don't know. I just know that I think the cloud and the AI bandwagon, a lot of younger kids or folks are jumping on because it's exciting, right? They're using AI. They understand that their stuff is in the cloud. They don't recall 4 walls of a data center and that their data is there. It's a very unique time.
So it's not really specific skills that need to be upskilled, for instance. It's the fact
Skilled
that people just
workers
aren't really interested in this area anymore because it's not the sexy, hot, exciting new thing.
Yeah, it's skilled. Yeah, skill sets or skilled workers in that specific area. So the level 1 guys now have to be this SD-WAN architect and figure out how to trouble an SD-WAN, issue. And that's why vendors like Broadcom are trying to make it as easy as possible. Click here, root cause there. It was red, now it's green, you know?
Excellent. Great. Good stuff. All right. Jeremy Rossback, Chief Technical Evangelist at Broadcom. Thanks for the presentation and putting the whole series together. Really well done. Thank you.
Thank you, Dave.
And want to thank, of course, Broadcom for sponsoring this micro webinar series. And of course, our loyal followers who keep coming back to watch us. I do want to let you know that all 3 episodes will be available on demand on itopstimes.com, so you can watch it over and over again to your heart's content. So until the next series, I'm Dave Rubenstein, Editor-in-Chief of IT Ops Times. So long for